In this video we will be training Humanoid with deep learning. First we are going to get an overview of how Humanoid works. Then we are going to understand how algorithm works, which in this case is Proximal Policy Optimization or PPO. It is just a neural network. Then we are going to train and visualize results of this humanoid robot after its training. So let's start. This is internal structure of robot. Now to move this robot, we have to control the robot with some actions. We have total of 17 joints with their IDs ranging from 0 to 16. Each joint gets a torque ranging from -0.4 to +0.4. This robot gets total of 17 torques at different joints to stand or to move every time. Now the question is how to get those values of torque which can be used to stand or move the humanoid robot. For this we get observation from the robot. We get total of 348 inputs from robot to generate torques accordingly to move the robot. These values can range from +infinity to -infinity. The observation space encompasses the robot's body part positions, velocities, mass, inertia, joint forces, and external forces, providing a comprehensive view of its state. Now the question is how to guide the neural network to give us accurate torques from robot to stand and move. To guide the neural network we add concept of reward. This reward is just a numeric value and goal of the algorithm is to maximize the reward. First part of the reward is healthy reward. This reward is dependent on the center of humanoid robot on z-axis. This value is 1.4 at start, with some randomness. If the value is between 1.0 and 2.0 then reward will be 5 for every step of the play. The purpose of this healthy reward is to ensure that the robot remains in an optimal standing position, maintaining balance and posture. The forward reward ranges from 0 to positive value, where the reward is positive when the humanoid moves forward in the positive direction along x-axis. Control cost is a negative reward to penalize the humanoid for taking actions that are too large. Contact cost is also negative reward to penalize the humanoid if the external contact forces are too large. Overall goal of these rewards is to guide the reinforcement learning algorithm to learn torques which will help humanoid to stand and move in positive direction along x-axis. Now, if we apply random torques, you can see the humanoid will immediately fall down. To prevent this, we need to train a neural network to determine the right amount of torques at each step to keep the humanoid standing and moving in the right direction. Second play also uses random weights. Humanoid falls down again from random torques applied to its joints. For the details you can visit gymnasium documentation, where you will get further details of the environment. Now let's understand the algorithm we are going to use to train the neural network for this humanoid task. Before going to algorithm, there are few things you should understand. Consider a simple state represented as S1. This state value is just an array of 348 values. This is observation we get from the environment, which in our case is humanoid. To get the action values, or in other words torques, we feed those states to the neural network. Network gives us the action values. These action values are just torques for the humanoid robot. You can consider them as policy of the network. By taking action we also get a reward. Starting from the state S1, we take action A1 using neural network and get reward R1. And we move to the new state S2. We take action A2 using neural network and get a reward R2. By repeating the process we get collection of stats, actions, and rewards. What we did is take a state from the environment. We took action with neural network. We got a reward by taking that action. And we moved to new state. We repeat this process to get all the state, action, and reward pairs. Each pair of state, action, and reward is known as a time step because we move to a new state after taking each action. Remember, all these rewards are collected based on the rule we discussed when discussing the environment. These are just rewards we collected from the environment. For understanding the discounted rewards, I am just using simple reward values. Consider we just got one reward at the end of episode. At all the other steps we got reward of 0. These are not actual rewards from the humanoid robot. These are just for you to understand the discounted reward concept. Now these new rewards are what we want to calculate. These discounted rewards are calculated based on rewards above. Here are values of these rewards with discount of 0.9. These rewards can easily be calculated using this formula. This discounted reward is a very simple concept. We take reward at time step t and add it to discounted reward at time step t plus 1, multiplied by discount factor. When we are at start, we will get a reward of 1 after taking 9 steps. So at start its reward value is in discounted form because it's at some distance from the reward at the end. Here we got a reward of positive 1. We can also get reward of negative 1, and this will also change discounted rewards for entire episode. We can get rewards at multiple points and calculate their discounted rewards at each point, and you can see how discounted rewards change with multiple rewards. We will get multiple rewards after episode. Here episode is one play of the humanoid robot which consists of multiple time steps. Now how to find if the reward at each point is good or not. In other words, should we go for this policy in future or not? This is the data we collected. Our goal was to find out if these rewards are good for us or not. Previously we had one network, which takes state as input. It produces an action from the given state. This is the second network we are going to train, which again takes state as input. It produces a scalar value as output for given state. This value is expected reward if we follow current policy. Here are all the values generated for all the states using second network. We take state st where t is number of time step. We get action at for this state. Similarly, we get value for time step t using the second network. But remember, our goal was to calculate whether the reward at a given time step is good or not. But how to find out which reward is good and which reward is not good? For this we calculate the advantage value for each state. This advantage at every step is calculated with this equation. This advantage at time step t is calculated using reward at time step t minus the value at time step t. Remember, reward is discounted reward, which tells us how much reward we got by interacting with environment with current policy. And the value tells us how much reward we expected from current policy. Now if the advantage is positive, it means we expected less and got more reward. So, we should take this action more often in the future because this is a good action. And if the advantage is negative, it means we expected more and got less reward. So, this action is not good and we should take this action less often in the future. This action value is deterministic and we get it from policy network. But here we want to use stochastic policy, which we sample from distribution. In PPO, when the advantage is positive, the old policy is updated to encourage actions that have worked well, increasing their chances to reinforce good behavior. When the advantage is negative, the old policy is adjusted to avoid actions that led to poor results, reducing their chances to prevent making bad decisions again. This helps the new policy improve over time. This clip function is just to update policy slowly. You can further study this in detail in original PPO paper. To update second network, we just take its mean squared error with discounted reward. This was just an overview of proximal policy optimization algorithm with some basic understanding of deep reinforcement learning. Our main goal was to train humanoid robot using this algorithm. You can study further details of this algorithm. Now before training, this is how results look like. Remember, you are viewing multiple episodes because as humanoid falls, new episode starts instantly. So, you are viewing episodes in a sequence. When we start training the algorithm, you can see that reward started improving with number of time steps. After 500,000 time steps, humanoid started to stand longer and hence it is getting some extra reward. This shows that algorithm is learning from the data. Now if we train about 2 million steps, you can see that reward gets higher. That means it should now perform better on results. After 2 million time steps, humanoid started to stand longer and also started moving along positive x-axis, so this means algorithm is working fine. Another algorithm named soft actor critic algorithm performs much better on just 500,000 time steps.